Good afternoon. Welcome, everyone. I know it's Thursday, it's 3 o'clock, so I applaud your stamina in coming and joining us for this session. So, data. Data makes the world go round. And your data is valuable and precious. But let's be honest, it's not really your data, or at least it doesn't belong just to you. That data is probably about someone. Someone has gathered that data, someone's entered it into your system, and ultimately someone's going to consume that data in order to drive business decisions and processes. So, we're over here from the UK. We're going to use some of those famed British manners that we're known for, and use the alternative title for our session, which is Who Are You and What Do You Want? Really, all those different personas that I mentioned are different users who have entrusted us with their data. And we need to be good custodians of that data, which means we need to be skeptical about any incoming requests and check who are they and what do they want, and decide whether or not we're actually going to serve that request. So you know the drill by now. We're not going to be talking about anything forward-looking, but as always, base any purchasing and investment decisions on functionality that's available today. A little bit about us. My name is David Frode, and my co-presenter is Matt Wood. We are both senior software engineers and engineering team leads at Financial Force. You can find me on Twitter using that Twitter handle. And just a bit about Financial Force. We're an ISV. We deliver a bunch of different solutions on the Salesforce platform. Our flagships are accounting and PSA. But we also do billing and revenue management and a range of other solutions. If you want to find out more about us or the products we sell or the work we do, just stop by booth 1507 and say hi. So what we're aiming to get out of this session, there's going to be some demos. There's not going to be any code. I apologize for that, but we're going to keep it high level. And this is really what we want to cover. Try to understand some of the high-level concepts, learn how to speak the language of identity and access management, cover off some of the more common authentication flows. There are many, many different authentication flows. We're just going to focus on the most commonly used ones for the purposes of this session, just to stop you falling asleep, really. And along the way, hopefully, we'll learn some best practices. Identity and access management boils down to this one sentence that we've taken from Trailhead. And it's about getting the right people, the right access to the right resources at the right time. If any part of that problem statement isn't in place, then we should not serve that request that comes into our org. We should protect that data.
So why are we looking at this? Basically, security and productivity. Your data and your customers' data is really important. So we want to adopt a couple of principles when looking at that data. The first is the least privileged one. So going to various sessions, you hear that you should only give customers or your users access to the data that they need. That's also true of your apps. The appropriate level of access for that app should be given. So for example, if you've got a connected app connecting to a service and it doesn't need to use chatter, then you should exclude that from the scope. If it needs access to use your SQL APIs, then yes, it does need the API access one, but it doesn't need chatter. Those security assets. But then you've got how your users then connect, log in, and the way that they usually do that is through multi-factor authentication. So that's using two channels in order to get to your data. Usual example, I log in, go to my laptop, do username and password, get a notification to my cell phone, approve, and then I'm in. The next thing is empowering users, so productivity-wise. I get into the office in the morning, and I've got 6, 7 apps that I immediately need to use. As a developer, I've got Slack, Stash, Salesforce, Gmail, etc. And if I had to remember all the passwords, given that I'm struggling with my lines here, you can imagine how hard that would be. So using Salesforce Identity Management stops you doing that. It also, from an admin point of view, reduces bad password practices. It's really bad to have people using password test123, do a Google search, and millions of people do this. Admin-wise, they also use a central account management system, allowing you to onboard and offboard customers really easily. With the range of apps and identity management, you then enable seamless workflows through your services and solutions. There's a negative side of it, of when it goes wrong. So if you don't do this properly, then there are direct costs and indirect costs. The direct costs are that you compromise your customer or your employee data, business plans, financial data, and your IP. Those are all bad, and then to fix them, it can result in downtime. Following that, you then enter a phase where you get the indirect costs, fines, litigation, damage to reputation, and share price. Doing a quick search, I found immediately got this headline, 11 of the worst data breaches, and got Washington Post, BuzzFeed, Facebook. These are all, fairly substantial companies, and if they get it wrong, we want you to avoid doing that.
Okay, so as promised, we're going to cover some core concepts. So let's start with identity or authentication and access management authorization, where authentication is about verifying the identity of the user. When we receive the request, we need to check who it's coming from and which application they're using to make that request. And we need to check the user that it's acting on behalf of. Once we have verified the identity, and we'll come on to that shortly, we need to decide if we're going to service the request based on the security model that's at play at that particular solution. So making sure that the user is doing things that they have legitimate reason to do. Let's revisit the problem statement from earlier. We're trying to guarantee the right users getting access to services and resources. And in order to do that, we use something that's in Salesforce represented by a connected app, where a connected app is really just a bundle of metadata configuration. And it really formally describes the service that we're trying to connect to, which users should have access to that, and the authentication mechanism. So an identity provider is going to act as the registry for all of the users within all of our systems. So there's one central registry for all the users, managing all the identity information, and any downstream applications, any service providers are going to interrogate that registry to find out if a user is who they say they are. Additionally, it might provide additional details like locale and time zone of the user. Examples of identity provider obviously include Salesforce. That's why we're talking about it today. But any third-party web app that implements the OpenID protocol. So you can see the usual suspects there. You've got Amazon and Microsoft and Google. But if the out-of-the-box solutions don't cut it for you, or you've built your own custom solution, you can always implement a custom external authentication provider, which implements that protocol. There's two main types of IDP, ones that use SAML, which is XML-based for performing security assertions, or the more modern equivalent, which is OpenID, which is more API-friendly. It's just an identity layer built on top of the OAuth specification. Moving on to seamless access, really we're talking about SSO, single sign-on. I won't go through all of those things, but I think we all agree SSO is a good thing. So the one that I want to focus on is the one at the end, because we're partners at Financial Force, and this is why we're really interested in identity and access management, which is that different solutions are good at different things, and the best solutions are ones that can span different systems and seamlessly provide access to the user without any friction, without getting them to have to go to log-on screens constantly. So we are going to augment the existing functionality and add some real customer value. So the service provider is the thing that's going to be requesting the authentication decisions from the identity provider. But once it's done that, it may need its own representation of the user. So it might have another account for the user. It could be an existing account, and that will need to be mapped back using some kind of external ID to the registry and the IDP. Or it may just provision a new account on demand, say if it's an infrequently used service. Not all the users are using it. Okay, and services and resources. We should probably define what we mean by services and resources. Services, we're talking really about any kind of API that's exposed in a system off-platform. So things like cloud storage, Dropbox, Google Drive, all of those things, analytics services, for aggregating all of your data, or really domain-specific things like tax calculations or payments. And the resources in those systems, it kind of depends on the system that we're talking about, but we're talking about things like record data, files, and other assets. And we need to operate on two different levels of security. We've got the high-level generic permissions, or scopes. You've probably seen these before, so things like when you install an application on your cell phone, and it says, so you're going to install this, it wants access to your camera and your contacts and your messages, and then you start going, well, I'm not sure about that. I don't know if you need that. But really, this is the chance for the application to declare its intention to access sensitive data. So this is a really important part of the system where the user provides their consent for that application to access that data before it goes to the identity provider. Once we satisfy the high-level permissions, each solution will define its own custom security model, which we should respect. So in the case of Salesforce, we're talking about CRUD and FLS checking, sharing, and org-wide defaults, and just all the general stuff that you're probably well familiar with. And then on the flip side of this, we need to keep the bad guys out. Our systems are exposed on the public internet, which means that they are constantly liable to attack. So in order to keep the bad guys out, we need to protect the secrets that we've been entrusted with. This isn't just passwords, this is API tokens and refresh tokens, anything that is password-like. So we need to be encrypting that data at rest. We need to not be holding onto it for longer than we need to, making sure that we're using secure channels for transmitting that data. If the user account is compromised and the user no longer has access to the account, we need to be able to revoke the access unilaterally. So doing it remotely, and we'll see an example of that in the upcoming demo. But just to make sure that once the account is compromised, we still have some fallback. And it's really important to set a reasonable lifespan for any access. It shouldn't just last forever. We should say it can last for minutes or hours, really whatever is suitable for that use case. But generally, you wouldn't be talking months or years. So choose a suitable lifespan. Other things you can do are enforcing multi-factor authentication, which we touched on earlier, and if appropriate, impose other restrictions like whitelisting the IPs or making sure that users are only logging into the system during normal business hours. Okay, so it's demo time. In the first tab, we have a standard Salesforce org, and in the second tab, we have a different system, Workbench, which you may have used in the past. You'll notice looking at the domain, this is not Salesforce, even though it's the product provided by Salesforce. So this is all free stuff you can just take away and try out for yourself as soon as you finish this session. You've probably done it before, but we will be highlighting some interesting things. So the first thing we're going to do is log in. And when we log in, you'll notice, if you look at the domain, we're no longer in developerforce.com. It's delegated to the Salesforce domain, which is the identity provider in this case. We enter a username and password, and Workbench never sees that information. It doesn't need it. And we're asked to verify the scopes of the application, and we can choose to deny that request. which means that we get the authorization denied error as we'd expect. So let's try that again, but this time let's accept the connection. Okay, so once we're in Workbench and we've accepted, we have the chance to use a variety of different Salesforce APIs. We're going to try a really simple one looking at SOQL. Let's query the accounts that exist in this org. Okay, so we get 5 accounts back. If we flip back into the org and go to the appropriate settings page, we can go to the connections page in setup, and this is a list of all of the different integrations that we've authorized. So a couple there from SFDX, but also the Workbench connection that we just created. We can see the created date, last used date, the name of the application, and how frequently it's been used, giving us really valuable information. And also the ability to revoke access remotely, which I said was really important. So if we revoke access and then attempt to use the API a second time, then we would expect that API call to be rejected, which it is.
So digging deeper, there's several methods of authentication that Salesforce provide by default. My go-to guide has been the digging deeper into OAuth page, because I'm looking at it from a more developer point of view, trying to establish a process where I can get apps like this to work. So if we start with the one that David's just shown, there's the web server authentication flow. This is used when the user's present, and once you've gone through the flow, gives you an access token in order to then request to validate other resources. But what happens if you're doing server-to-server communication, if you want to integrate 2 technologies together? You can either choose SAML or JWT, JSON Web Token. Both of these flows act when the user isn't present to authenticate without users interactively logging in. The 4th flow that I want to touch on is a username and password flow. So this is using explicit username and password in the request, which we'd recommend don't use it in production. Use it if you want to do quick proof of concepts. Now, the reason for that is if you provide the username and password, that's going to the resource that you don't want, that doesn't want access to that information. Also, if you provide that and you're doing server to server, then if someone changes the password, then it's going to break your flow. From a user perspective, going through the demo, user requests access to the protected resource. They then authenticate. And if 2-factor authentication is set up, they then verify their identity. In this case, it's via an email verification code. That then goes and asks the user for the level of access to the connected app. And then you can get the protected resource, run the SOQL queries that you're after. As a developer, I'm more interested in what's going on behind the scenes and wanting to explain that. So, going through the same flow, Workbench requests access to the protected resource. Then it goes to Salesforce. Salesforce is the resource owner and also the authentication server in this case. Usually in different server environments, going to what we're going to do in the upcoming demo, they'll be different. Once you've requested access, Salesforce sends a grant in order for the user to log in. Once the user has logged in, then Workbench can exchange the code that's been signed by the authorization grant and get an access token. Using the access token that Workbench has, you then get access to the protected resource. said that we were going to show a different demo without having Salesforce as both sides. So how have we used this as a partner? Our flagship product is PSA. It is a solution that allows people to create projects and assign resources to those projects. And with those things, it then allows them to do expense reports and time card approvals. This is the example that we're wanting to do, but we're wanting to incorporate a separate solution, Slack. I'm sure that the majority of you are aware of Slack, that it's a business messaging service. They want to connect people via channels in order to make their users productive. Our aim in this was to provide a nice user experience for both users of PSA and Slack. With that. On the left-hand side, we've got Beth logged into our PSA product. She has had a project assigned to her. She's gone out on a business trip and incurred an expense. She's come back into the office and then created an expense report that her manager needs to approve. So going into the expense report, we can use standard Salesforce functionality in order to submit it for approval. Once it's submitted for approval, we'll also get a notification on the right-hand side, which we can then approve. Slack says that it's approve a request, and the status in Salesforce is approved. So that looked really quite simple. You know, what's the big deal there? Well, there's a number of different components to that integration that we've created. Using Astro as the example of the submitter, he hits the Salesforce APIs. He says, I want to submit an expense report for approval. That then fires a message to our service using standard Salesforce features. So you have an approval process with an outbound message associated with it. At this point, we do the authorization request using the connected app that we've created earlier. Get the response back, which point the outbound message is responded to. And in the meantime, the report is being submitted, and Astro can see that. At the same time, our services have gone and requested record data from Salesforce, saying, I want the expense report. Then got the record data, formatted it in a really nice way, fired it at Slack, and then the approver can see that message. In this case, we've chosen Cody as the approver. Sends the approved message and goes through the auth flow. Difference here is that we've got to go through the approval process because Cody might have different permissions assigned to him than Astro does. So assuming that everything's right, can approve a record, record's marked as approved, it updates the message, and both users see that it's approved. I can see that. Looking at the authentication flow, we're using a different one to the username, the user flow that we showed earlier. There are a few subtle differences in this. The first is the connected app configuration has been changed, so instead of self-authorization, it's been changed to pre-authorized users. That means that the user must have a permission set associated with them in order to do the task. It's also had a signature added to it. What I mean by that is that we've generated a certificate where the public part has been added to the connected app, and the private part is stored in our service. Our service generates the JWT signed with the private key and sends it to the Salesforce API. That validates the signature, and assuming that everything's right, the audience issue a validity and subject check. The validity is the time that the request is valid for. With server-to-server stuff, it's in the order of minutes, no more than 4. Once that's been approved, we get the access token and request the resource.
Okay, so it's time to land this session and wrap up. These slides will be available, so if you didn't get a chance to take a picture, you can find the slide deck on the agenda builder, and I'll post it on Twitter as well. So, web security is hard. Let's not be under any illusions. There are very intelligent people out there who are persistent and sophisticated in their approach to compromising valuable data. So we need to be on guard against these outside forces. And also, it's constantly evolving. This isn't a static picture. New techniques are being developed by security experts, but also by hackers every day. So let's not be under any illusions about web security being something that is easy for everyone to just get to grips with. But don't let that put you off. This is well worth learning about. A little bit of knowledge goes a long way. And you can learn it. If you don't feel confident about it, just start small. Pick up a little bit at a time, work at your own pace, and use the resources that work best for you, whether that's videos or articles or guides. But make sure that you get your hands dirty, because there's no substitute for that. And we promised that we would try and help you to learn the language of authentication. So there's a little glossary there. I'll leave this up at the end as well, so you can come back to it. But all that's left, really, is to say thank you, and we'll open the floor for questions. Please come to the microphone, or you can find us afterwards. Thank you.